In this video, I will show you how to find what kind of symmetry each function has, algebraically. And the choices are even, odd, or neither. Now, figuring out whether a function has even, odd, or neither symmetry comes down to comparing three different versions of the function. One version of the function that we're going to need is negative f of x. And I'll show you how to find that in a second. Another version of the function that we will need is f of negative x. And of course we will have the original function f of x. Once you compare f of negative x to the original function and the opposite function, you can tell whether it's even, odd, or neither. Okay, so first of all, how do you find negative f of x? For negative f of x, you just change all the signs. So in this case, negative f of x will be negative x to the third power minus 6x. Done. Now, how do you find f of negative x? Well, this means you substitute negative x in place of x. Like this. And we just have to simplify this down. When you raise something negative to an odd power, the negative does not go away. So this will be negative x to the third power. A positive times a negative is a negative, so negative 6x. Okay, so we have our three versions of the function now. So here's what it comes down to. Look at this blue function, f of negative x. If f of negative x equals the original function, it's even. If f of negative x equals the opposite function, then it's odd. If it doesn't equal either one, then it's neither. So let's see, negative x to the third power minus 6x. It does not equal the original function, but it does match the negative function. So see how this matches this. So we will say since f of negative x equals negative f of x, it is odd. So notice, even if you are able to look at the function and tell at a glance that it's odd, you're not going to get credit just for knowing that it's odd. It's all about using algebra to justify your answer. Okay, so you have to, this is like a proof. It's not about just knowing the right answer, it's about proving it. Okay, let's do a couple more. So again, the first thing you need to do is write down the negative version of the function. I'll squeeze it in up here. So negative g of x is going to be negative x squared over x plus 1. Okay. Now we need to find g of negative x. So that's going to be negative x squared over negative x plus 1. So g of negative x will equal, when you square something, that negative is going to go away. So I will have x squared, and I'm going to factor this negative sign out of parentheses. So if I factor this negative outside of the parentheses, I will have negative, and then I'll have x minus 1. Now I'm going to look back to see, does g of negative x match the original function or the negative function. If it matches the original, it's even. If it matches the negative version, it's odd. It clearly does not match the original version. It's got this negative in here, and it's got x minus 1. But you know what? It doesn't match the negative function either. It's got the negative, but it has x minus 1. Once you pull the negative out, you have x minus 1, where it should be x plus 1. So it doesn't match either one. So we're going to say since g of negative x does not equal g of x or negative g of x, it is neither. All right, and you know the options are even, odd, or neither, so I'm just saying it's neither. All right, let's do a couple more. All right, number 31. First of all, I'm going to white this out, and instead of y, I'm going to put f of x so it matches what we're doing. Okay, so let's call it f of x instead of y. So there's the original function. Now let's write the negative function, which I always do in red for some reason. You probably noticed that. So feel free to copy me and be awesome like me. So this is going to be negative f of x, and that will simply equal negative 1 over the absolute value of x. So we have the original function and we have the negative function. Okay, now we need to do f of negative x. So this would be 1 over the absolute value of negative x. Okay, so this would be the same thing as 1 over the absolute value of x, because that's what absolute value does. So that's it. So this is f of negative x. Does it match the original function, or does it match the negative function, or neither? Well, I see that it matches the original function. So we will say since f of negative x equals f of x, the original function, it is even. Alright, if it matches the original function, it's even. If it matches the negative function, it's odd. Okay, last problem. Okay, so this time they did not give us f of x per se. Alright, this time they did not give me y by itself, or f of x by itself. So hopefully this will turn out to be even, because I'm actually not 100% sure what it will look like if it is odd. But I know that if I replace x with negative x and I get the same function again, then that's going to be even. I know that. So let's see what happens if I replace x with negative x. So this will become negative x plus 3 squared plus 8y squared is equal to 16. I've replaced x with negative x. Now I could factor out the negative sign here. I can't factor it all the way outside of the exponent, so I'm actually going to have two sets of parentheses for a second. So I could bring this negative sign outside of parentheses and have negative x minus 3. Okay, plus 8y squared is equal to 16. Now, this even exponent is going to make this negative sign go away. So this would be the same thing as x minus 3 squared plus 8y squared is equal to 16. So this is definitely not even because it does not match the original function. It became x minus 3. I'm not actually sure if it's odd or not. I don't think so. You know what? The negative version of this function would be if I multiplied one side of this by negative 1. Is that true? Nothing I can possibly think of that would be the negative version of this function. If I multiplied, maybe if this was a negative 16, or if I had a negative here and a negative here, none of that happened. So I'm going to declare this to be neither. Alright, I gotta be honest, I'm not nearly as comfortable with this version as I am with a nice f of x to work with. But I'm pretty sure that my answer is correct. Alright, let's extend our conversation of even, odd, or neither to graphs. A function is going to be even if it's a function in the first place. It has to be a function to be an even function. It'll be even if the y-axis splits it right down the middle. The classic example of an even function is the parent function y equals x squared. See how the y-axis splits this right down the middle? This is an even function. You will have an odd function if you could turn it upside down and it still looks the same. For example, maybe I'll go out of order and I'll jump to this one. This is a perfect example of an odd function, because if I were to grab this and turn it upside down, I like how it's nudging the other graphs out of the way, you can see that it still looks the same as it did before. Watch, I'm going to hit Control Z right now, which should snap this back to the way it was before, and you'll see that it didn't change. Bam! Okay, so if you turn it upside down and it still looks the same, it's an odd function. Of course, it has to be a function. It needs to pass the vertical line test. So we're supposed to put a box around odd functions. I feel like using a highlighter pen, so it'll be really fat.
Like me.
Aw. So this is definitely an odd function, so I'm going to put a box around it. This one would have been an odd function if the center of rotation were at 0, 0. But this is not odd. It's neither, because the center is not at the origin. This one over here is neither. It would look completely different if I turned it upside down. The y-axis doesn't split down the middle. Both of these are neither. And this first one is not a function. So I want to say that it's even in a way. It definitely has y-axis symmetry. That's what I can say. This ellipse has y-axis symmetry. But it is not an even function because it's not a function at all. It fails the vertical line test. So not a function. So I don't get to circle anything because there are no even functions shown here. And my only odd function is this one that I put the big box around. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.